Are you ready to learn printed circuit board design? I've been designing PCBs for 30 years, and I'm going to share my secrets with you.
The next best practice in this pillar would be FPGA-PCB optimization. The problem: FPGA design methodology is inefficient in its ability to optimize FPGA pinout configurations. The roadblocks: it's too much overhead to set up, implement, and maintain, as well as the FPGA tools are good enough even if they don't consider layout. The best practices for this pillar would be to utilize the FPGA-PCB integration, as well as to configure the FPGA pinout routing optimization, and to enable FPGA pin swapping capability. The value you're going to get from these best practices would be reduced design cycle time, optimized FPGA-PCB integration, as well as reduce or prevent EMI or SI issues, a tightly integrated integration, as well as you're going to remove the potential for errors or respins. Now let's take a look at an example of FPGA-PCB optimization.
When using an FPGA in a design, bridging the gap between the FPGA and PCB domains is crucial for optimizing the FPGA I/O within the context of the board. Using the FPGA-PCB co-design functionality of Expedition, groups of signals can be created easily to manage the complexity of high pin count FPGAs and accelerate the pin assignment process. These groups can be treated as separate HDL entities within the tool and can be created manually or extracted from an HDL file. During the component placement and orientation on the board, floor planning using the FPGA-PCB co-design can be done before and during the PCB layout process. Users can also make FPGA pin assignment changes to optimize routing. Early on, this can result in fewer netline crossovers. However, during the entire design process, the benefits can include reducing layers, minimizing signal integrity issues, shortening traces, and reducing the number of vias used.